Okay, the next concept is free electron theory. What is free electron theory? Free electron? Okay, now to explain this, I will consider an atom. So this is an atom I have. It consisting of the central nucleus and surrounded by electrons. These are the electrons, right? Here also there are many electrons. Here also there are many electrons can revolve around the nucleus. Now let me consider an example of semiconductor. Can you give? Already I told example for semiconductor. That is correct. Germanium. Yes, germanium is a semiconductor. What is the atomic number of germanium? That is 32. 32 is the atomic number of germanium. That means there are 32 electrons in germanium atom. There are 32 such electrons can revolve around the nucleus. Now, can all the electrons can fill in the single orbit? If this is an orbit, all the 32 electrons can fill in it? No, it's not possible. Now, in the germanium, there are 4 free electrons in it. There are only 4 free electrons in it out of 32 electrons. So only 4 are free. They can move anywhere in a germanium crystal. If this is a crystal we have, the electrons can move anywhere in the germanium crystal. That is, only 4 can move. But on what basis I am telling only 4 electrons are free in it? So answer is here, and that is the rule called as 2n square rule. What is this rule says? Here this is the first orbit, and for this I will call n is equal to 1 for this orbit, and for the second orbit here it is there. For this orbit n is equal to 2, and third orbit is here. For this n is equal to 3 I will call, and for the fourth orbit n is equal to 4, and so on. There are many such orbits. Now maximum of how many electrons can fill in it out of 32? Not all 32 can fill, only few electrons can fill. That is, 2 electrons can fill in it. Then why 2 only? That is given by this formula, that is 2n square rule. That is, for n is equal to 1, substitute n is equal to 1 in this formula. So 2 into 1 square, that is equal to 2. This is only 2 electrons. Maximum 2 electrons can fill in n is equal to 1 state. Not more than that. That is Pauli's exclusion principle formula only it is. Now, for n is equal to 2, you tell me now. For n is equal to 2, how many electrons can fill? For n is equal to 2, substitute this n is equal to 2 in this formula. So 2 into 2 square, this is equal to 8. So maximum 8 electrons can fill in this orbit. So similarly, in n is equal to 3 orbit, use the formula and find maximum number of electrons can fill is 18 only. And now tell me how many electrons can fill in it. That is 4th orbit. So in 4th orbit, maximum 32 electrons can fill. Beyond that, it cannot fill. So maximum 32. Okay, now germanium has 32 electrons. In the first orbit, 2 electrons can fill. Right? Out of 32, 2 can fill here. And next, in second orbit, 8 more can fill. And next orbit, 18 more can fill. So total how many already filled till here? So 2 plus 8 plus 18, that is equal to 28 electrons can fill till the orbit 3 till here. 28 electrons can fill till here. But 4 more electrons are there out of 32. So where these 4 electrons can fill, there is in next orbit. So, but what is the capacity of this orbit? The capacity of this orbit is 32, but only 4 left with us. So those 4 are free electrons or valence electron. Maximum 32 can fill, but only 4 left. So it is not completely filled, and this is valence electrons. There are 4 valence electrons in it. So if you have a germanium atom, so there are only 4 free electrons. They can easily flow in a crystal, germanium crystal. Now I will consider many germaniums together. There is a germanium crystal. You can see the germanium crystal here. This is a germanium crystal here. Germanium atom, there are many such. It can continue here, everywhere it can continue, and few I taken. Now this germanium has 4 free electrons, correct? 4. And next this germanium has again 4 valence electrons. This germanium again have 4 valence electrons. Continues everywhere. For this germanium 4, and for this germanium again 4 valence electrons. For this germanium 4, right? And one more is here. Again there are 4 in it. Now there are 4 more. So there are many electrons here. You can see 4, 4, 4. These electrons will form a bond. This germanium share this electron, and this germanium share this electron, and forms a covalent bond. So this also form a covalent bond. These 2 electrons form a covalent bond. These are the bonds called as covalent bond. These bonds form at absolute 0. That is at absolute 0. That is 0 Kelvin. There is very low temperature we cannot imagine. So such a low temperature at which these all electrons are involved in the bonding process. So no electrons which are free. These electrons which are not free, this also made with one more germanium a bond. This electron also made a germanium bond with that. Now no electrons which are freely available to move in a germanium crystal. So at absolute 0 there is no current in it, because if the electron is not flowing from one place to another place, no current in it, correct? So at absolute 0 this germanium crystal acts as a perfect insulator. That is, it doesn't conduct any current. Now I will just start giving the heat to it. I am not giving the heat. The nature itself has an energy that is at room temperature, that is around 300 Kelvin. Compared to 0 Kelvin, it is very, very high temperature. So if you take this germanium crystal and place it at the room temperature, what happens? These electrons gains the energy, that is heat energy. After gaining the energy, what happens? It just start vibrates. This electron also start vibrates. All the electrons start vibrate about its mean position. It vibrates. After vibration, what happens? These bonds gets break. All the bonds gets break. Then what happens? Once the bond is broken, these electrons now can move freely anywhere in a germanium crystal. Any electron in it, they can move freely anywhere on the surface of the germanium crystal. So that movement of electron constitutes electric current that is possible at high temperature. So at absolute zero, this crystal acts as an insulator, perfect insulator, and if you start increasing the temperature, what happens? Its conductivity increases, start conducting the current. So the points are here at zero, absolute zero. The semiconductor acts as a perfect insulator, and at high temperature it acts as a conductor. Remember these points, students.